hi everybody. Excited to be here. Okay, everything's working. I'm really excited to be here in AngularConnect again. I love this conference, and I hope you're having a good time. Yeah. All right. So today we're talking about dynamic components. So just and dynamic components it is. With Angular, who's using Angular? Okay, great. So I'm in the right place. Good, good. Okay, awesome. So, Josh introduced me, and thank you. And so I don't have to say a lot about this slide, only that, yes, I love Angular. And pictures from a recent ngGirls event that we had. So let's start with the interesting stuff. Demo. So we're talking about dynamic components, or dynamic components in this case. Does anyone here, is anyone not familiar with this screen? Okay, great. No hands raised. All right, so this is the application that if you create a new application with Angular CLI, then this is the component that it builds for us, just as an example for what we can do. So is this a dynamic component? No, probably not. It doesn't look very dynamic. Now, if I click here, maybe. Do you see this? This little thing? This is actually a color input. And now I can change the color. Wow. Is this a dynamic component? Well, no, probably not. It's got like changing the color according to the input, but that's it. OK, let's close this. Now, if I click here, is this a dynamic component? Well, it depends, kind of. Well, we'll talk about what a dynamic component exactly is, so it kind of depends on the implementation. But I'm sure you'll agree with me that this is a dynamic component, right? Very dynamic. OK. So dynamic components aren't really about the component themselves. You can write a component and use it dynamically or statically. But a dynamic component is the way that you use it. So I have another demo here that really has dynamic components, where I add a component, and let's make the screen a little bit larger. Oh, that's a Chevisaurus list. Wow. Who is this dino? And let's add another one. Anasaurus. Let's see a bit more. Oh, Maxosaurus koretsky. So if you know Maxosaurus koretsky, he gave a talk yesterday, and he's been a real help with my talk. He gave me, well, I actually based a lot of what I'm going to show today. I got a lot of inspiration from his talks from previous conferences and his blog post in Angular in Depth. Let's see who else I have here. Oh, Igor Sminar. He's also been advising me for this talk. And, oh, Unisaurus JD. He was here just a moment ago. And he also helped me a lot. And we've got a lot more. Oh, Ulisaurus Shaked, Asimosaurus Hussein, Michaelosaurus Ladki. Wow, a lot of, ooh. OK, so the way that these components are, well, so these are Dino components. Each one is a different component. They're dynamically loaded. I don't know which component is going to load. There's kind of a math random there. But they're not hard-coded in the template. Let's see what other component. Oh, a lot of components I have, dinos I have here. OK. Let's see how. OK, I think we've seen enough dynamic components. Let's see a few more things that a dynamic component can do. Well, these components also get the name of the dino as an input, and we'll show later how to do this. And this is bit more complex example of dynamic components, where I'm, again, adding components, whichever component that I want. And I want to show you here that we've got change detection and dependency injection working here, even though it's added dynamically. So it's still an Angular component, so I can change the name of whoever said this quote. This is me. And actually, no, I didn't say that. I said something else, like, oh, hi, Mark. Yeah, anyone? OK, I can add a graph. Let's add 2 graphs. They have initial values, but they have the values also connected to the rest, to their parent component. So that's why if I'm changing one value, it will change in the second one also. So there's also change detection connected, and the data is connected to the rest of the application. Okay? So these are great examples, but let's talk really about what dynamic component is and why we need this, because maybe you don't trust me that these are dynamic components, because these examples can be also implemented statically. So let's talk first about static components, what they are. And static components are components that are usually just used in the template. We're using their selector and putting them in a specific place in our code, in our application. So in this example, we've got several static components: the app header that I've created, and the tab set and tab that come from Angular Bootstrap, app node that I also created. There's an app dashboard, and so on. So these are components that I know where I use them. The developer knows when they use them, where they use them, in development time. And they're kind of they're in a fixed location in the template. And you can say that they're kind of hard-coded, but it's OK, because this is the way that we're supposed to use most of our components. Okay? But if you need to change them, to change the location, then you need to go to the code and really move them from one place to another. So a great use case that we're having with lots of components is dashboard. Is there anyone here who hasn't been working on a dashboard in an Angular application? OK, a few lucky ones. Great. So let's say that you're developing a very generic dashboard. And you're developing all these types of components, types of graphs, tables, gauges, and so on. And then you and your team are developing tens or hundreds of different components. And the users are the ones who are going to decide what component is going to be shown and where and when, and with which data, right? And the users might not need all these hundreds of components. They might need only 5 types of them, 10 types, 20 maybe, okay? But not all the components that you've created. So if you're developing them in a static way, then you might have something like this in your code for every component that you have. So the user loads the configuration, which might be like an array of the components, and for each component, the component type, and then the data that they want to input into this type. And then you're doing an ngFor on this array, and you're doing an ngSwitch to see what type of a component you should show. And then you hard code all the types of the components, right? So here you can see only 5 components, but imagine that you have hundreds of them. Now, there are several problems there. So first of all, who wants to deal with code like that, with like a really, really big template file? We don't. You want to deal with that? Really? OK, you like to suffer. OK, but most of us don't, and it's not a really great experience for developers, and it can break very easily. Now, you might say, OK, so let's split this code into different components, like let's do split the template to children components. But we've already done that. We can't split this template anymore. Now, another big problem that we have in this code is that our application needs to know in advance, in load time, about all the components, all the hundreds of components that we have. It needs to load them all and compile them all. And we've got a lot of code that we're not going to use. Our user is not going to use because the user will use only 5 or 10 types of components. So this is a really big problem that we have. So imagine, just imagine, in our very perfect Angular world, that this whole template of thousands of lines of code can be rewritten in only one line. What do you say about that? OK, so in a moment, we'll see how it's done. Let's talk about several other use cases for dynamic components. Before that, let's just say a few more things about them. So they can be added in runtime. So the user decides in runtime what component to load. We can load the configuration from the server, like I said before, or from anywhere else. Maybe generate it on the fly, like I did now. And they can be lazy loaded. So you can wrap each component in an ng module and build it separately and load this module only if you need it. So lots of code that is not going to be shipped unless it's needed. Okay? So these are the basics, but we're going to go over the code again in a few moments. So the main use cases that there are for dynamic components. So the dashboard, like I explained. Data-driven forms. So these are still a bit hard to do. There are several methods that you can do them, like configuration-driven reactive forms in Angular. But with Ivy, we're going to have a lot simpler method to load forms and form components, form controls, according to the form data that we have. But even without Ivy, we can still see what data we have in the form and dynamically load. For example, if the data in one piece is text, then it will load a simple input. If it's of type date, it will load a date input, and so on. So you don't need to load different controls if you don't need them. Pop-ups and modals. So this is an example from Angular Material, and there are actually two dynamic components here. One is the modal itself, they call it the dialog, which they don't know, like they give you this dialog, this component, but Angular Material doesn't know where and when you're going to use it. And when you're going to use it, it can't be hard-coded in the template because it needs to be attached to the body element. So whenever it is used, you call a method that creates this component and adds it to the body, to the application, and removes it whenever you need it. And you pass data into it. And another dynamic component that we have here is the inner content of this dialog. So this is a component that you create by yourself. And you tell Angular Material, when you're creating this dialog, you tell it what component to load inside. And this way, you have only one dialog component with different components that can be generated inside. Okay? So again, dynamic. Another example is for content management systems. For example, a good example is Angular.io. It is built this way. So they have several components, which actually, well, the application isn't like hard-coded with all the documentation, and probably you've also seen the documentation of the code itself, like the classes and everything that you have there. So it's not hard-coded. It reads the Angular code base and generates the views, the documentation according to it. Okay? So it just loads whatever is needed. If it's a code snippet, if it's several code snippets that need tabs between them, if it's an example, then it's all loaded dynamically. And then you can also write the content without HTML notation. You can write it in MD file, for example, Markdown. Another use case that I've dealt with, I was developing an application in Angular that is used for creating diagrams. And the diagrams are in SVG, and we were using another framework for that that's written in Backbone. Yeah, I know. Well, Backbone is awesome, but we wanted to link it to Angular with the change detection that we love, and dependency injection, and everything. And the use case that we had, we wanted to have notes components in the diagram, where the note itself is an Angular component, where you can have the text, who has written this note, when, and you can also do some actions on this note, like change it or assign it to someone, and so on. So in this framework that's called Joint.js, they allow us to create HTML snippets and put them on their SVG elements. But if we want to connect them really to the application with Angular, and if we want to have an Angular component there, then we have to to load it dynamically, and to also manage its lifecycle hooks. And, for example, make sure that we call ng on destroy when we remove one of the components. A very good article about that is by Yuri Stromfloner, use dynamic components to render HTML for third-party libraries. He has a different use case there, but it has really great practices that you should use when you're doing that. Another example that I can show you is a plugin system. In this example, it's an application that allows teachers to create worksheets for their students, and they can choose from different types of questions. For example, we can see here a question where you can fill in the text or connect the dots. And there are different types of questions that they can use, and they, of course, put in the data, so like the text that will appear there, and then the students can solve it online. So the idea that the team had there is to allow developers from other teams, other places, other companies, maybe schools, to develop their own questions and to let the other teachers use them. So they will develop an Angular component. They will have the interface that we can use there, what inputs that we have, what events we expect, and they will develop it and ship us the code, and we'll add it to our application. And of course, these components are loaded dynamically, just like in the dashboard and in the other examples. Okay, another great resource about that is by Max Koretsky. He's given a talk, Modules Are Not What You Think They Are. You can search for this talk on YouTube. It was given in ngConf and also in ngTalks this year. So, let's talk just a little bit about how components are created in Angular. So we have our ng module that wraps everything, wraps our components and directives and so on. So in the declarations, we need to specify which components belong to this ng module. And then we use this component in the template. That's a static component. So Angular recognizes that and compiles this component, creates a component factory. And and then creates an instance of this component, which is a component view that has inside the DOM node and the component instance. And then it ships it to the browser that renders it. Now, this might change according to the compiler. It might change in Ivy, so don't rely on it heavily. But this is what happens generally in our application. So if we want to load a component dynamically, Angular doesn't know where it's going to be inserted and to which DOM node to connect it to with all the Angular framework that we have. Like I said, change detection, inputs and outputs, dependency injection. It doesn't know which injector it needs to use. So we need to add those components into entry components, and then Angular will know that it needs to create a component factory for them, but it will also create a host factory, which connects it to the surroundings wherever it is. And the root component that we have is actually also an entry component, but because it's there in Bootstrap, then it is already also given the same things that an entry component has. And you can check what type of factories Angular creates if you're inspecting your code. And sorry, this is really, really small. I'll get, oops, too big. Okay. So let's go to sources. And you have here ng and all the modules that Angular has created and compiled. So let's, for example, see the app module. So you can see app component, ng factory, and everything that's there, but we won't go into details of that, and this will also change very soon with Ivy. And we can also see that app component has an ng host factory. So that's the surrounding for letting it connect to the body element or wherever we put it. The same, well, the demo component is a static component, so you can see that it only has an ng factory and no host component there. But we also have the Dyno modules, which have the component factories and the component host factories there. So you can see which component has what and how it's being used. Okay. Okay, so how do we do this? How do we insert the components? So we need a reference to the place in the template where we want to insert the dynamic components. So this is just one method to do this. I'm putting a reference VC, that's for view child, and then I hold this reference in the class as a view container ref. Then when I want to add the component dynamically, I need to resolve its factory first, because Angular has created a factory, but I need to get it. So we have a component factory resolver for this. We also need to create then the instance from the factory with the injector that we have on this component, or maybe on its parent component, whichever injector that we want. And then we insert it to the view container ref. Now, but this is the long version. Can you imagine that? It's only a few lines of code, and it's a long version. If you don't need to hold the component ref itself, then you can skip it and just create the component directly on the view container ref. And then you even don't need the injector, because it will be added automatically. How do we pass inputs and outputs? Well, so then if we do hold the instance of the component ref, so it has the instance member on it, which is actually the instance of the component itself of the class. And we can connect to all its members and events directly, as long as they're public. And so this is something we can do. But you need to know that in this, if you're doing it this way, then ng on changes will not be called when these inputs will change because we're not using the input itself. Okay, so, but you can still use ng do check. So I think you've seen a different method of wrapping it so that ng on changes will work. If you need it, then that's cool in the previous talk. What about content projection? Yes, we can do that. The content that you want to project will be added as a parameter to the instance creation. But still, if you've noticed, it's not 100% dynamic, okay? Because we need to know about the component that we're creating ahead of time. This means that we need to import this code into this file. That means that this code will be added to our bundle. So what do we do about that? We're creating dynamic components, or plugin components, you can call them, or lazy-loaded components. So they are unknown in compile time, and they're lazy-loaded. How do we do that? Well, oops. There are different ways to load them. In this case, I'm using Webpack and the Angular's methods that we have in our application, in our code already. Angular gives us a loader, an ng module factory loader, which actually comes, well, it is used also in the router. We'll see that. So you need to either use the router, then it will provide it, or you can provide it by yourself. And then you just load a string. And a string, it doesn't need to be known, like the file itself doesn't need to be known in your development time or in build time, because it's just a string. And you can load this, the string from the server, for example, if you have several different components, modules that you want to load. This string is for the module, because we can't just load a component dynamically. We need to load, not dynamically, but lazily. We can lazy load an Angular module. So we're loading the module. We're creating it from its factory. And then we can create the component that we have inside. Okay, so this is the way that you will provide the ng module factory loader. This is the way that it is done in the router using system.js, actually. And if you want to build parts of your code, some Angular modules, lazily, with the Angular CLI, with the Webpack, then you need to add these modules to Angular JSON over there in lazy modules. Okay, but still we have a bit of a problem because we resolve the component and we still know the component there. So what can we do about that? We can use the providers. This is the lazy loaded modules. So we can add the providers there, and we'll ask for the provider. We need to know the provider name, the string, but that's it. We don't need the code. Okay? So this is one way to do that, or if you want to be more safe with the types, then you can actually create a whole interface and injection token, and then you can just provide this token. And this token will be known in our application and also in the ng module that you're loading. And now you can just get the widgets token that we have, that we've resolved with the injector, and get its value from this module. Okay? And we just get the component from over there. And now it's perfectly lazily loaded. So what do you think? Have we succeeded in our mission to make lazy loaded plugin dynamic components? Yeah, all right, great. I think we achieved this. Okay, so a few things that you need to consider. You can load modules in several different ways, and one way that you can do this today is also with ES modules, dynamically loading them. But you should check whether you're using Webpack, which will use it, do something else with that. So maybe you should choose a different build system to do this, maybe System.js. You can bundle a different project as a library without having the whole application that it needs. Just put in the Angular JSON of it, vendor chunk true instead of false. You'll find it there. And then it will not bootstrap the application and everything. The next step that we're going to have that will be safer to use dynamic components, to use others' components, is with web components. So you should check out how you're going to do that if you want to allow, for example, components written in different frameworks or even in different versions of Angular. Okay, because components written in version 6 will not be loaded as you expect in version 7 if they're used dynamically. And of course, in Ivy, we're looking forward for more improvements in this area of dynamically loading everything. So these are the resources that I've mentioned. And also, another thing that I know that I'm already taking a few extra minutes of your time, but another great thing that I want to show you is the demo by Manfred Steyer, who has actually different types of components. A regular one, let's a lazy-loaded one, and an external component that is built as a web component. So please check out his code. And that's it. I hope you're going to use now dynamic components a lot in your applications and see how they improve your performance and your code quality. I'll be now in the Q&A session. You can ask me questions there. And I hope you enjoyed the talk. And if you want to help out or ask anything, then you can also reach out to me in these channels and help us with ngGirls. So thank you very much.